Yes, welcome back. Now we are looking at question 9. What is in front of us? Question 9, right? So question 9, it's a probability question. Okay. So yeah, this is a probability question. Okay. So yeah, there is a lot that you've learned on probability. Now we need to use what you've learned to answer this question. So what is it that is in front of us here? Let's see. They gave us 9.1. They are saying here two events A and B are such that the probability of not A, okay, is equal to 0.5. The probability of B is equal to 0.3. The probability of A or B is equal to 0.685. Are events A and B independent? Justify your answer. Okay. So they want us to prove that these two events independent. Okay. So yeah, how do we go about doing that? How do you go about doing that? Okay. So yeah, we have to do a calculation, obvious. So then what type of a calculation are we supposed to do? This is what I'm about to do right now. So are the two events independent? So to prove that two events are independent, right? To prove that the two events are independent, what do we need? It should follow that probability of A and B is equals to the probability of A multiplied by the probability of B. This is how we prove that two events are independent, okay? So now, what is the probability of A? Let's see. Probability of A, do we have it here? It is not there. We have the probability of not A, you see? So they gave us, what did they give us? Okay, let's take out everything that they give us. They give us the probability of not A, which is equals to 0.45, okay? And they gave us the probability of B, which is equals to 0.3. They gave us the probability of A or B, which is equals to 0.685, okay? This is what they gave us. So now we are saying for us to calculate the probability of A and B, right? Okay, we have to see like probability of A and B, it must be equal to the probability of A multiplied by B, right? Do you have the probability of A and B? That's the first question that we must ask ourselves. We have the probability of not A here, the probability of B. So we don't have the probability of A and B, right? How can we get a probability of A and B? The probability of A and B through the addition rule, what does it say? Okay, we know that the addition rule states that the probability of A or B is equal to the probability of A, right, plus probability of B minus the probability of A or A and B, not A and B, right? A and B, yeah. And it also means A and B. So now A or B is given to us as 0.685, okay? And then the probability of A, we don't have the probability of A, right? How can we get the probability of A? We know the probability of not A, right? So from the probability of not A, it follows that the probability of A plus the probability of A not A is equals to 1, right? So which means the probability of A will be equal to 1 minus the probability of A naught. A naught is the same as probability of not A, so it's going to be 1 minus 0.45. So what is 1 minus 0.45? Yeah, I'm going to put it here. This is why I have a space. Probability of A is going to be what? I've shown you the calculation. This is the calculation here. I'm just continuing with it here, okay? So 1 minus 0.45. This is a 0.55, right? So now we can proceed in substitution. 0.55, we have the probability of A plus probability of B, we are going to 0.3 minus the probability of A and B, okay? So now 0.685 is equals to 0.55, right? Okay, 0.55. And then, 0.55 plus 0.3. Yo, why am I repeating the very same thing? This is 0.85 minus the probability of A and B, okay? So now, I'm gonna take this one across. I have 0.685 minus 0.85 is equals to negative the probability of A and B. Okay, negative the probability of A and B. So now, with this being the case, what is it that we have? 0.685 minus 0.85 is equals to negative 0.165 is equals to negative the probability of A and B, right? Negative both sides, so when you drop down the negative, we're going to have the probability of A and B being equal to 0.165, right? So this is what we have. So now we want to prove that the probability of A and B are independent, right? So now let's find out. Okay, probability of A and B must be equal to the probability of A multiplied by the probability of B, right? So now, let's see. For it to be independent, if it doesn't satisfy this condition here, then it is not independent, right? So now, what is the probability of A? Probability of A is 0.55 there, 0.55 multiplied by the probability of B. Probability of B is 0.3. Okay. So now let's see. 0.55 multiplied by 0.3. What are we getting? This is 0.165, right? Right. Since the probability of A and B is equals to the probability of A multiplied by the probability of B, it means, right? It means that the probability of A and, it means that event A and event B are independent. This is the condition. So you see, these two events are independent. So that was 9.1. That was 9.1. So now we are faced with another question on 9.2 there. Just got to do with the Venn diagrams. Okay. So Venn diagram. So let's see what is it that is happening with the 9.2. So here they are telling us that a survey was done amongst a group of 75 learners to determine which sport they watch on television. Okay, this is what they're telling us. They chose from athletics, netball, rugby. Okay, some of the information that was collected is as follows. Okay, 12 learners watch netball, rugby, and athletics. Okay, so you see the Venn diagram. Let's go back to the statement. The survey was done among a group of 75 learners. So the total number of learners, which is S, it's 75, right? And then they are saying a survey was done among a group of 75 learners to determine which sport they watch on television, right? They chose from athletics. This is athletics, right? It is on the Venn diagram. Network connectivity, it's starting again, but we are going to thrive. Let's hang in there. There we go. So athletics, there it is. Okay, and then they chose athletics, netball, there is netball, and rugby. Some of the information that was collected is as follows. So 12 learners watch netball, rugby, and athletics. So the keyword there is "and," so which means it's union of the three events, right? So there is the, as you can see. And then 25 learners watch rugby and athletics. So 25 watch rugby and athletics. So which one is rugby and athletics? Rugby and athletics. So you see, rugby and athletics. So now the two, you see where the two unites. This part here, this oval part here. Actually, here we're just focusing on some of this question. So you see this part here, right? Rugby and athletics. Okay. rugby and athletics, which means the rugby and athletics part is what? This is the 12 plus B part. It should be giving us 25, right? And then since we are seeing that B is the one that is unknown, then what are we supposed to do now? We can simply find the value of B by saying 25 minus 12. And doing that, what is it going to give us? It's going to give us B to be 13. So this one here is going to be 13, okay? So yeah, that is what they mentioned there. 25 learners watch rugby and athletics, okay? The keyword there is end. That's where the two events are uniting. Then 22 learners watch netball and athletics. Netball and athletics, okay? So the 22 learners, they watch netball and athletics. So this is netball, and then this is athletics. So what does that mean? So you see there, this 12 plus A. 12 plus A, that is going to give us the 22 learners, right? So it means A there is going to be what? A there is going to be 22 minus 12, okay? So 22 minus 12 is going to be 10. So 8 there is going to be 10, okay? What else? Did 8 learners watch rugby? So the total number of learners who watch rugby is 38, okay? So you see, in rugby, how many learners do we already have? We have 5, okay, we have 5 plus 12 plus 18 there, okay? This is the one that I'm talking about. This is 5, this is 12, and this is 18, right? These are the total number of learners that we already have. And all in all, they make 8. So which means C is the number of learners that make rugby only. And that is what? That is 38 minus the total of 5 plus 12 plus 18, which we found that is 8. And that is 8 there. Okay? So that is it. 5 learners watch what is it? 5 learners watch only netball and rugby. So 5 learners watch only netball and rugby. So you see, 5 learners they watch netball and rugby only. Okay, so you see, where is it? 5 learners watch only netball and rugby. So there it is. It's indicated there. It's just a union between netball and rugby only. Okay. All right. Then what else are we supposed to work out here? Let's see. And then they said 4 learners watch athletics only. So there it is. And then the total number of learners there was what? Total number of learners was 75. We don't have D, right? So what are you going to say for us to find D? For us to find D, we're gonna say 75 minus the 9 there. Okay, minus 9 plus 5 plus 12. I mean, yeah, plus 12 plus 8 plus 18 plus 10 and then plus 4. And then D happens to be 14, okay? So yeah, like we were just interpreting the Venn diagram according to a statement that they gave us there, okay? So now 9.2.1, determine the value of A, determine the value of A, B, C, and D, okay? Determine the value of A, B, C, and D. We have already done that, so I'm just gonna write them here, okay? 9.21, we have already done that. So we saw that A is equal to 10, B is equals to what? B is equals to 13, C is equals to what? C is equals to 8, okay? And D is equals to 14, okay? We've already done that. So now, if I'm to redraw the Venn diagram, let me redraw the Venn diagram just for the sake of making our work to be easy. Okay? So yeah, then I have 1, No, this is not working. Let's work with the Venn diagram that they gave us here. This thing of me drawing Venn diagram is not working. So now 9.2.2. Calculate the probability that the learner selected at random watches athletics or both netball and rugby. Okay. The learner that is chosen at random watches athletics. So athletics, it's either you watch athletics, okay? You watch athletics or query. The person is watching athletics. What is the probability of watching athletics? Athletics, okay? So let's interpret the question 9.2.2, right? They're saying calculate the probability that the learner chosen at random watches athletics, right? So this is the whole of athletics. Athletics, how many people makes the event athletics, right? So athletics, as you can see there, so there, athletics is what? You see? Oh, yeah. At least this is the whole of athletics, right? So people who make athletics, it's what? 10 plus 12 plus 18, right? Plus 4, okay? This is the whole of athletics. And how much is that? 10 plus 12 plus 18 plus 4. That is 39, okay? This is the whole of athletics. And then he's talking about athletics or both netball and rugby. So they're talking about netball and rugby right now, okay? Both netball and rugby. So the intersection of netball and netball. So I'm gonna put there and rugby, okay? So what is the number of N and rugby? N and rugby, let's see. N and rugby, okay? So N and rugby, as you can see here, this is what? 5 plus 12. Oh, 5. It's only 5. Rugby is 5. Netball and rugby only, it's only 5. Okay, so it's 5. So which is 5 over 75. Now the probability of netball and rugby is 5 over 75. The probability of athletics only, you see, probability of athletics only is 39 over 75, right? So now, what does the question say to you here? The question said to you, yeah, right. Calculate the probability that the learner selected at random watches the athletics or both netball and rugby, right? So you're gonna say the probability of watching athletics or netball and rugby is gonna be what? 39 over 75 plus 5 over 75, right? And this is gonna be what? 39 over 75 plus 5 over 75, okay? And it so happened that it gives us 44 over 75, which is equals to 0.59, okay? 0.59. So that is how question 9 will have been solved. And this is where it ends.